Hello everyone, I hope everyone is doing good. So in today's video, we are going to look into the different chunking strategies in RAG. We'll understand what are these chunking strategies. We'll see its practical implementation. We'll look into the code of it. Then we will have a data set on which these chunking strategies will run. On the same data set, we'll run predefined questions and the base answers, and we'll calculate the recall and the MBR points, MBR number, and we'll try to understand that which chunking strategy is relevant to this kind of data set. So for the demo purpose, I'm going to use the retail domain data. So I already have the setup, and I'll just show you what is the project setup currently, and according to the project setup we'll look into each of the chunking strategy so that you will have the theoretical plus practical setups both together in the same video. So this is the project setup in the VS Code. Okay. So as I've mentioned, I'm going to use the retail domain data. So I have the product master data. It's a small data set, but it doesn't have all the information. It's just one way of showing the data. The other bigger data set which I have is that MD file, retail catalog MD file. You will get it from the internet. You can download it. So in this, you have the product comparison guide, which product have goes into which category, what is the rating and what is the price. And then there is a customer service scenario also. There multiple things are there. Warranty policies are also included into this. The product like what is the specification of this of the particular laptop or particular product. So each kind of information is given. So in this kind of text file, we have all kind of information of a particular of a multiple product. And in master, in this one, it's a normal comma separated a kind of semi-structured data set. The other thing which we have is the question set, in which we will be giving some questions. While when we'll calculate all the kind of chunks, then we'll be running the questions on that. So we have the section. This section shows the base answer, like which laptop has 32 GB RAM. So section 2 contains the laptop and computing, contains the actual relevant answer. So and in according to the base answer, our model or our evolution way will calculate that which kind of chunking is more suitable to these kind of data set and these kind of questions. So I have a list of all kind of questions which generally people ask in a retail catalog or retail online stores, like which product recommended for rainy weather. So it has all this product. Okay, so basically it's all about electronics product. The policy related stuff is also there in the input data. Then I have created each file for each chunking strategies, like 9 chunking strategies we are going to cover today. So first is the fix, second is the sentence. So each have a different Python file. We'll run this each Python file. We'll get an output of each Python file. We'll analyze their chunks, and then we have a evaluation.py, which will run on this model, sentence transformation model, and calculate the recall and the MBR, and then we'll understand the interpretation of that evaluation matrix. Okay, so this will give the complete picture of multiple chunking strategies. No chunking strategy is perfect for each kind or for all kind of use case. So for this particular retail use case, I'm going to showcase this. So maybe you have some banking domain, banking data set. In that case, the steps will be same, but that which chunking will be more relevant to your data set will differ. But this will give you a fair idea like how you can proceed to these kind of question in interview, and in the project how you can proceed with this kind of scenario. So we'll start the video now. First we'll see the fixed chunking. Fixed chunking, almost everyone knows that we read a file and then we give the size, like at which particular size each chunks will be created. For example, I have given the text size of 800. So after each 800, the chunks will be created, but I have also given the overlay of 100. Overlay of 100 means it will go till 800 and the next chunk will start from 700. So 100 will be the overlay. So I'll run this and we'll see the output now. Okay. So output JSON is created here. You'll see here. So this is my chunk ID. This is the strategy is the fixed one. So I have just given the program the outputs will be like this, and this is my first chunk. So this is my second chunk. So in fixed chunking, no logical chunks is created. It is created on the fixed number. So that context doesn't flow into the different chunks. Like if I ask the question like, show me the laptop which is having 32 GB of RAM, it may not be able to give you the exact answer. Okay. In our case, titanium is one of the laptop product which we have mentioned. It may not give you that kind of answer. The other chunk may have a different answer, the different answer. Like I mean to say, like chunk 002 may not have the continuation to chunk 110 with the kind of information. And also, while retrieving the chunk, when the actual LLM is being used, in that case, forming the answer from one chunk is not going to give you the exact kind of answer. So the fish chunking is not a very good chunking strategy overall in any kind of scenario, mostly in the business domain, because there is a fixed size of the chunk. Now we'll move to the another chunk, which is sentence chunking, where we divide the data, create the small chunks on the basis of the sentence. So in the fixed chunking, we have a fixed size. In sentence chunking, we have the linguistic sentence till the time the sentence is being written. But at that time, it will split the sentence and create the chunks. Okay. And one more thing, each chunking strategies will create a different number of chunks on the same kind of data. We'll see that also. So we are going to run the sentence chunk. Now you analyze this one, this JSON file. So it has all that sentences. Okay, strategy sentences. So it will not have that fixed amount of like the size of this text will be different from the size of this text. But in fixed chunks, obviously the size will remain the same. Now coming to the problem here, fixed chunks have the character boundary. Potentially the context is broken because there is no way we are going to give the we are in because there is no way that we are giving it the intelligence to understand the context. In sentence, we have a sentence boundary. We have better continuation of the line, but it doesn't mean that you have the continuation of the context. So it's a better linguistic integrity, but contextual integrity is still missing. So for this, we'll move to another chunking strategy, which we call as a paragraphs. So this will understand a paragraph and create a chunks out of that paragraph. So we are going to run this paragraph chunking. Now we have the output of paragraph chunking here. So here also your text size will differ depending on the size of the paragraph. So in fixed chunking, we have the character based splitting. In sentence chunking, we have a sentence based splitting. In paragraph, we have a paragraph based splitting. Now, what if your paragraph itself is 2000, 3000 words? So then it becomes very big. It becomes very difficult to get the contextual meaning out of it. It may give multiple other answers which you don't need from your questions. Okay. So for that, we'll move to the recursive chunking. This is very interesting to understand. So recursive chunking is very different from other chunkings. Other chunkings we are using just the manual what instruction we are giving, like split on the character, split on the sentence, split on the paragraph. But in recursive, you'll be using the recursive chunking. We'll look now. Let's pause for a minute and understand that what is recursive chunking. So recursive chunking is a chunking strategy where document is split recursively. Recursively means you go inside one directory, then again go inside the other subdirectory. So recursively, you are going inside the hierarchy of the separator and starting with the large logical unit like paragraph, and then it will move into the sentence, it will move into the word, and it will move into all the smaller chunks till the time it doesn't get the desired size. So it will go through first paragraph, then sentence, then word, and get into the character. So you see in this flow, it reads first a paragraph. If paragraph fits in its size, then yes, that is the chunk. If it doesn't fit, then it goes into the sentence. If the sentence fits into the size, then yes, it's okay. Otherwise, it will go into the word, multiple words. So why we use recursive chunking? Because it preserves the natural document structure. Like if a person has written a paragraph, then there is a contextual meaning in some of the sentence out of the paragraph or inside some portion of the paragraph, or a paragraph may contain multiple different kind of meaning. So that is preserved in this kind of chunking. It's an attempt to keep related sentence together. So related sentence will be kept together, means a try will be made to keep it together. Works well with the document of varying length commonly used in the RAG pipeline. Obviously, all the chunking strategies which I'm talking about is mainly related to the RAG pipeline, and it also allows you to control the chunk size and the chunk overlays. Okay, now we'll go into the. Now you see here also we are giving the size. Here we are also giving the overlay. Okay, so it goes through the paragraph, sentence, and word to find its correct size. Right. So we have you run the recursive chunking? No. So, so this also contains the text of very different kind of size, but it will have more meaningful text. Now we'll go to another different kind of chunking, which is a structure aware chunking. So in the structure aware chunking, the according to the structure, like if your document contains title, it already contains the section which it contains in our use case, our data set. Then we need to use this kind of chunking where the document will be first looked into. If you have multiple documents, then what is the title of the document? It will preserve that. It will preserve the chapter. It will preserve the section, subsection, paragraph, and everything. So the output will be like chunk one, what is the section and what it contains, what is the subsection and what it contains, and what is the actual content. So advantage is it has the hierarchy. Like if you have a PDF, for example, a Wikipedia page, if you do the chunkings in based on the structure based chunking on the Wikipedia page, then there are multiple sections in the Wikipedia page. So each section name with its definition and with its content will be preserved in each chunk. Yes, chunk size will become big, but it will have the relevant data. So now if you want like 32 GB of RAM, so your chunk will not just contain a 32 GB of RAM, it will contain laptop name with the 32 GB of RAM in the same chunks with other specification and the policy related stuff for that product in the same chunks. So advantage is it preserves document hierarchy and keeps related information together. Means the policy of the laptop name and specification in the same chunks. Better retrieval context. So this is very good, but it takes time. Like if you have a large amount of data and documents and the documents are huge, then this kind of chunking will take some time to create the chunks. Fine. So we'll run this structure chunk. Now we'll go to the structure chunks. You see here, chunk ID, strategy section, and what is the text inside that section. Then another section, and okay. So that section, if the section is very big, it will have this two chunks having the same section name, but the content will be different. You see here, the content is wireless audio, Sony bit. Here it is wireless audio. Warranty part is here. So this is the structured chunks. Now we'll move to another chunks which is called semantic chunks. Okay, this is also very important. Now the semantic chunks is really very interesting. So if you already know RAG pipeline, if you don't know RAG pipeline, go to my previous video. You will understand every aspect of the RAG pipeline, and there are practical videos also. So in RAG pipelines, we understand that the embeddings are created only after chunks are created. When we do the chunking, and then after that embeddings are created. But in the semantic chunking, we create the embedding before the chunks is created. That means I'll tell you, like for example, there is a sentence. We create the embedding of that sentence, and there will be multiple sentences. So multiple sentences will have the embedding created. The similarity between that embedding, obviously embedding is created to create the similarity, semantic similarity between the sentences. So embeddings are multi-dimensional numbers which are assigned, or are the number assigns to each of the chunks or each of the data. So in this case, we have not created the chunks. So we have multiple sentences. Each sentences embeddings are created. Similarity between the embeddings are calculated. If the similarity drops, then a new chunk is created. If the similarity continues, then chunk size will increase. This is very interesting. And once the chunks are created, after that again the embedding will be created on that chunks, created new chunks to store it into some of the vector database. So this is one of the chunking strategies, semantic chunking strategies, where we create or we use or we apply embedding before creating the chunks. Okay, now we'll run this semantic chunks, which is number 6. Okay, so it will take time because it's creating the embedding, understanding it, and then creating the chunks. This process will take time. So now semantic chunks. Okay, boundary threshold is also been, yeah, given there. Retail product, fictional omni-channel retail company. Okay, wireless headphone, Sony Beat. So it contains all the information of Sony Beat. Fine. Now, laptop computing, so it contains Novabook product, Novabook category. So, like it's a specification, processor, all kind of specification will be there because the semantically these both these lines are together. RAM and the storage are together. So the semantic, these two things are together. So we understood what is semantic chunks. Now we'll move to another interesting part, which is parent-child chunks. So in parent-child strategy, chunking strategy, what happens is there is a parent chunks and there is a child chunks, and both these chunks are related to each other. Now you see, I have one section, like for example, this is for a data set of insurance. So general liability, what it contains coverage, it contains limits, conditions, and exclusive. So your child becomes coverage, limit, condition, exclusive. Now in the rag, when someone asks any questions about coverage, so these child chunks will be passed to the LLM, plus the information of the related parent chunks are also passed to the LLM. So generally to the LLM, when we ask question to the RAG pipeline, the chunks data or the extracted data, retrieved data is passed to the LLM. In this case, the particular matched data is also passed to the LLM, plus the related data to that particular chunks is also passed. So if I ask a condition about the limit, what is the limit of this coverage? So it will understand that this is the child. So this child is a separate chunks, but this chunks also contains the information of the parent document, which is general liability, and it will return everything related to its parent chunks to the LLM. This will create a chain of context, a chain of meaningful information, which will be passed to the LLM. We'll run this now. Okay. Now my parent child chunks are created. So what is the parent ID of this child? Okay, and this is 00. Fine. Here it is 0. Like this is the child 001. Its parent is 000. So this is the parent chunks. Okay. So if this is given to LLM, then this plus this both will be given to the LLM. Okay. Now see here, 001 is the parent. Okay, fine. And the child is 002. Okay, sorry, child is 002 and its parent is 001. Here these two will go together. Understood? So this is called parent-child chunking strategy. Now we'll move to the contextual chunking. We have two more chunkings to cover up, and then we will move to the evaluation matrix. Okay, this may be a longer video, but it will give you a full context. I thought of making it into different videos, but then again I thought, like, if I give everything in a single video, that will be more logical if you go through a video from the starting to end. So we'll go to the contextual chunking now. So we looked into semantic chunkings where embedding was created and contextual chunking. So contextual chunking is a kind of similar kind of structure chunking, but not exactly structure chunking preserve the full structure. But contextual chunking will get that data, particular chunks, and the information related, like which section it is or which is subsection it contains. Okay, so it has the section or kind of some other information apart from that particular chunk information. Like in the parent child, we have a parent child relationship. In contextual, we will have the exact chunk plus anything related to that chunk, like any subsection, any category related to that. So that will be also taken into account. So we'll run this contextual chunking. Okay, we'll see the output. Okay, output will like it will give the section, wireless, and the text. It will give the section. Okay, only till section, but it will not preserve the full structure, which is done in the structure chunking. Now look to our last one, table aware chunking. So in table aware chunking, generally this is good for a tabular data. Now, for example, in this MD data also, retail catalog also, it will contains the in the tabular form, or you can see there is one more input master .csv file where we have the column name. So it will create a binding between the values and the column name. For example, velocities of which column, footwear is of which column. So this will have this kind of information. Like tabular information is preserved in a document chunking fashion. If we have information in more CSV format or tabular format, then this kind of chunking is very important in that category. Okay, so it will create a chunk out of that tabular data and preserve the meaning of the column and its values. We'll run this. Okay. So okay, content type text section is not known. If they were not aware of the section, strategy is this one, and this is the text. Now we have got all the output, fine, all the output of these 9 chunks. Now we are going to run the evaluation.py. So this evaluation.py, what it is doing, it is getting all the JSON, all the sorry, it is looking into all the chunks. It is also getting all the questions from this JSON. Now I would have shown you the question file where we have the question and the ground truth. What is the actual truth? This section contains the actual truth, and it will compare with the actual truth and the retrieval truth to compare and create the recall and the MBR value. Okay, so we are using sentence transformer so that no embedding is being created in this process, and it will do the comparison, and it will take out the top 5 top 5 of the output. So we have mentioned k equal to 5. Okay, you can change this. Okay, and then you can have another kind of output, but for this example we have taken k equal to 5. So we'll run this evaluation.py. So this video is not about explaining each code, otherwise it will become a very long video. So this video actually is about uh, demonstrating the different kind of chunking and how the chunkings are different. Okay, so if you want the detail of each code, please post in the comment. I'll come up with the detailed video specific to the code, like what is written in the evaluation.py, why we have done in this way, why this chunking strategy is written in this kind of code, what's the meaning of that. So that we can cover in a different video. If you want, you can post in the comment. Second thing, if you want the full project code, I can put it in the GitHub. I can just put it in the description. If there is not in the description, put it in the comment, like you want the full project setup and how to do the setup, what are the dependencies. I'll just give you the link. You can download it from there. Just but you have to put it in the comment, then only I can and understand that how many people are interested in actually running it on your own system. Like I'm running on the Mac system, you can run your own system. Lightweighted system can also work. In this project we have the input data, we have everything. You just have to import into VS Code and do some dependencies installation, and it will be in the execution folder. Okay, I'll run the evaluation. Now it will create some output, recall value, and then it will create the MBR. We'll analyze that thing. See. For each of the chunks it has created, means strategies, fiction, sentence chunk, and you see here, each chunking strategies contain different number of chunks. That means that for same amount of data, same kind of data, different chunking strategies will generate different number of chunks. Fine. So there are the recall values and MBR values. So what is recall values? It's a top 5 values. Recall values means is your relevant answer comes under top 5. So how many times? Like you see here, for this fixed chunks, in 14 chunks, 70% of the 14 chunks has the answer in the top 5 values. Fine. Now you see here in the recursive chunk, all 15 chunks have the relevant answer. Fine. And what is that answer? I'm talking about this answer. Answer means this is the question, this is the answer. Okay, this question has been fired to each of the chunks, and this answer is expected. And if it is not expected, obviously the recall and MBR values will vary accordingly. Now you see here, for a recursive chunk, it's 100%. For structure chunks, it's 100%. And for contextual chunks, it's 100%. This is the recall value. What is MBR? MBR will tell you, sorry, MRR will tell you that at what level, how high is your answer, relevant answer. Means in top 5 your answer is there, but is your answer in the third position, first position, or the fifth position? That information MRR tells you. So you see here, the higher the values, the better is the chance of getting the answers. So in the chunking strategies where MBR is high, if you change the K value to 2 also, then also you will get the correct answer. That means your answer probability of getting the answer is high. Means it's at the top level, not just in the top 5, it's in the top 2 or in the top 1, top 3 level. Right. Now you see here, 0.8, it's a very good number, and this comes under structured chunks. Now recursive chunks, it comes under 0.7, 0.84, 81, 84. So recall is also important, but error is more important than recall. So I'll consider dot this 84% plus 100% of recall. So for my use case, this retail data set, the contextual chunks becomes more relevant, and we can take this as a benchmark for this project. And then whenever our data size changes, or after a few days, or when our RAG system start performing hallucination, in that case we again have to revisit and try to look into this benchmark of 100% recall and 84% of MR. Fine. So similarly, you can take contextual, you can take, yes, parent child is also fine, but recall 100% should be there, so that there is 100% chance you will get the answer in top 5. Okay. So these three, recursive, structure, and contextual, becomes very relevant to this retail use case. I hope you are able to understand this all chunking strategies and how we are getting into the details, like which chunking strategies is relevant to your use case. See, each use case will demand a different kind of chunking strategies. Just knowing the chunking strategies doesn't give you an upper hand that you can fine tune the RAG. So for fine tuning the RAG, your basics, your fundamentals should be strong. That is your chunking strategies. Then you should understand how you should apply this to understand your project structure. Now you cannot apply this chunking strategies to all the very large amount of data, all the full project data. You can take the sample of data and then apply and get the benchmark number. Like this number should be there for all kind of data. Plus minus 10% of the variation can be there. So this way, like if you're going into the Gen AI interview, RAG interviews, and this kind of presentation, if you present your answer in this kind of way, not obviously running the project there, but in theoretical way, so that will make a different impression there. I hope you'll be getting good knowledge from this. Any doubt? You want me to deep dive into any one of the chunking strategies, code review? Then if you want the full project GIF file, just post in the comment. Also post your feedback. We'll meet in the next video. Till then, goodbye and happy learning.